In this video, I'm going to speak a little bit about my history with breeding plants and animals. Welcome to the Art of Breeding with Brian Reeder. To begin with, of course, I've already stated I grew up on a farm. My grandparents on both sides were subsistence farmers. I was surrounded by people who relied on animals and plants for their existence and who were breeding them. In addition to my grandparents, I had great aunts and great uncles who were also involved in farms. Specifically, I had a great aunt who, her and her husband and his family had a large farm, and we lived close to them. So I was constantly being exposed to people who were breeding stock. By the time I was 5, 6, 7 years old, I had my first chickens, and guppies were first for fish. My grandmother always kept a small aquarium in the kitchen when I was a little kid, and of course I eventually had to have one of my own. So from very early on I was exposed to, they tended to keep like an angelfish. It was usually like an angelfish in a 5 or a 10-gallon aquarium for whatever reason. Later my uncle had an Oscar fish, but I think my earliest fish were guppies, and then a little later after that came the goldfish. When I was about 6 or 7, my aunt had built a house and bought daylilies from the Gilbert H. Wilds catalog, and I got to order one at the same time. And my first daylily cultivar was a diploid called Winnie the Pooh. At about 6, 7, 8 years within that time span is the first time I'm trying to breed chickens, and of course I'm not real good at it, and I don't always succeed, but the bug is there, the fire is lit. And so as I get older, 8, 9, 10, 12, I'm still keeping goldfish. I'm trying to breed them. Occasionally I'm successful. I'd bred guppies for a while. That was very easy to do, and so that was the main thing I bred in those earliest years. I would occasionally breed chickens, and I didn't know anything about hybridizing plants, really. I think I got the book The Peonies by Dr. A.P. Saunders, when I was probably, I want to think, 12 years old. That's about the same time I started reading the Dune books, and really the Dune books introduced me to the first real concepts of these long-term breeding programs. Even though it's in a sci-fi setting, it's still the concept. I mean, Frank Herbert, who wrote Dune, for instance, bred chickens. So he bases his Bene Gesserit breeding program in the Dune series on his own work with breeding poultry. So that's an interesting, another tie-in there with those books. All along the way in my younger years, I'm being introduced to more and more concepts of breeding. We would get like the Stromberg's catalog and Murray McMurray, and you would see, and back then Stromberg's carried everything. I mean, every animal you could get, they carried it. So there was this concept that all of these things were being bred, and then I was obsessed with pets and pet stores and people breeding animals. We would find people out in the country who bred chickens, and we go buy a chicken from them, or go buy a pair or a set. So by the time I'm about 13, 14, going into my teen years, I've already got quite a lot of experience with keeping plants and animals, breeding animals, and like I said, when I read the book The Peonies by A.P. Stout, that was my first real exposure to the notion of breeding plants. I mean, I knew that people kept corn seed and grew corn. We kept marigold seeds, but the notion of how do you breed a daylily? I remember thinking, people are actually breeding this. How do you do that? Wouldn't that be cool? Not knowing that it was easier to breed a daylily than it is to breed a marigold. It's easier than breeding corn. I don't think there is any plant on earth that is easier to breed than a daylily. But I didn't know that at the time. And so there was this whole thing. I remember getting the Gilbert H. Wild catalog each year and seeing all the new daylilies. And the new daylilies were so expensive. I remember when post time was $100, and that was like, if you could just breed these new daylilies, they'd be worth so much money. Of course, I was a child, so I was impressed with childish things. So there was this whole thing. I remember having these like fantasies of being, breeding these new breeds of chickens. This was always a thing with me. I was always wanting to breed new breeds of chickens, new breeds of goldfish from very early. I would see like the traits of the celestial or the traits of the lionhead and the traits of the veil tail, and I would think, well, why can't you put the lionhead with the veil tail? Not knowing that they had those in China. Why can't you put the traits of the celestial onto an Aranda? All of these concepts always are, why can't you combine all of the traits together? Why can't you get a pearl scale with a crown? Of course, we didn't know there were crown pearl scales in those days. Why can't you get a pearl scale with an Aranda or a lion head with the celestial eyes and no dorsal fin and broad tail and all of this kind of stuff? So I know you can do it. I knew then it was possible to do, and I would talk about stuff like this when I would go to pet stores or to chicken breeders, and they would look at me like I was crazy, like this kid's crazy. I even remember my mother telling me one time, after we'd gone to one of the pet stores and I was telling them what I wanted to breed to make in the goldfish, and she was like, just don't tell people stuff like that. They just look at you like you're crazy. And she cared. She only cared. But I knew this stuff was possible even then. I don't know why. Maybe it was just the exposure to the fact that domestication had created all of this from basically scratch. Goldfish, with all their fancy traits, came from these dull, gray, crucian carp. So I knew if you could make the breeds, that the traits in the breeds could be combined to make new breeds. So I was either looked at as crazy, or looked at like some kind of abomination. The true goldfish breeders who were breeding the fine goldfish breeds were like, oh, you're just going to ruin goldfish. You can't create new breeds. I remember someone telling me that it's not possible to create new breeds, and I thought, were the goldfish breeds on the Ark with Noah? Someone made these in the last few hundred years. I always had this sense, but going into my teens, then I started to actually breed things more seriously and gain more skill, more proficiency with breeding things. And basically, it was just growing up and being mature enough to have the consistency and the persistence to do it. So in my teens, I started keeping snakes as well. I kept both pythons and boas, and I bred some boas, and I got a python pair here or there to mate, and I would raise a few offspring. You'd have offspring, you'd maybe keep one or two, you'd take the rest to the pet store and trade in for whatever, a new aquarium or food for them or whatever. So it was a neat little thing. I saw that there was a viable pathway to doing stuff with this. By the time I was about 17, we opened our own pet store. So I started breeding things more seriously then. And by that time, I've got a little bit more proficiency. And then I went on to college, and I continued to breed snakes while I was in college, and I dabbled with breeding fish some there. I was going to go to school for conservation genetics to work in zoological parks, and I decided that was not something I wanted to pursue because there was too much. Zoos are a business, and the business considerations come before the conservation considerations in most instances. I saw too many instances of things like zoos deciding to put down animals because these weren't popular with the public. So these don't make a good display. They're perfectly viable. Maybe they're even mildly endangered, but there are plenty of them in captivity, and we don't sell animals, and so we're just going to put all these down. It turned me off with the whole thing. So after that, there's a period in my life where I just decided to kind of leave the animals behind. I was really over the whole thing at that point. And so I just started to pursue my art more. I'd continued to do art and pattern making and paint and all of these things throughout all of this. And I focused on that, and so for several years I just worked in pattern making and design, costuming for stage and stage design and that kind of stuff. And I did that for several years. And then I reached a point where I was just tired of doing that because I kept running into animals. And during that time, I did own an albino Burmese python. And I did have some aquariums. And I tried to dabble with goldfish. And I ended up keeping some angelfish for a long time. And the goldfish eventually died, of course, And the angelfish, I ended up giving those to someone when I moved. The Burmese python I brought back with me, I ended up selling it. The animals kept they were just there. I couldn't get away from the animals and the plants. I wanted to be back to nature because I was living in a city. I was living in an apartment. Of course, I had a couple of animals. I had an aquarium, a couple of aquariums. I had the snake. I couldn't breed and dabble with plants and animals the way I wanted to. And so I decided, okay, I've got to get... And living in cities kind of kills me. It's a little much. The human noise level is a little hard on my sensory system. So I just decided I've got to get out of this. I've got to get back into nature. I've got to get to a place where I can work. And I had a house between college and going to work in design. I had actually built a house back on the family farm, and we'd been renting it. And so I decided to move back, took care of everything with that, came back, set up to just breed some chickens. I was just going to breed long-tailed chickens. I wanted to have some Yokohamas and some Phoenix. I was going to crossbreed them and make some new color forms and just play with it, and it was not going to be a thing. And then a friend from college had gotten in touch with me, someone who I had been in touch with, had kept in touch with, but said, I know you have an interest in chickens. I am doing some work where I'm going to do some research programs or some research projects. Would you be interested in participating in that? And maybe you could keep the animals and do the matings, and then you can send me samples and we'll do the testing. And so I said, sure, yeah, that would be interesting. It would be fun because it appealed to the scientist in me, the science side of me that wanted to be doing more than just dabbling with a few chickens. So we set that up. We began. That's in process. This is the early 1990s. So then by chance, I had an outbreak of disease in the flock. And it was what was then called chronic respiratory disease. And, of course, now I know what that actually is. It was manifesting as, like, coryza and just basic respiratory hacking and sneezing and coughing and swollen eyes and mucus and the whole 9 yards. And I found I would go to the vet, I would get the medicine, I would treat them, they would get well, you would take them off the medicine, 2 weeks later they're sick again. And it became this recurring cycle. And so finally I took samples to the university here in my home state and got the testing done. And they said, oh my God, they've got mycoplasma, you've got to depopulate the whole flock. Well, little did I know that all birds just about have mycoplasma. Yes, there are a few chickens, a few of these big poultry industry houses that are basically like airtight, where they have basically fumigated the eggs and removed the mycoplasma, and they allegedly have mycoplasmal-free flocks. But I can tell you no one else does. If your birds are breathing air that has ever touched a wild bird in North America, your birds have mycoplasma. If you've ever been to a poultry show, if you've ever bought a chicken from a catalog, flea market, or a chicken trade, an animal trade show, or whatever, your birds have mycoplasma. So in time, I was noticing that even when you would bring in new birds, they still had mycoplasma. Lo and behold, there was no way to get rid of it. There was no way. It's not curable. There's no cure for it. Once they have it, they have it. And they all have it. So I started digging through the scientific research and basically, I then turned back to someone who I had probably pestered considerably as a child, who was F.P. Jeffries. He was a poultry scientist and poultry breeder. I was a precocious child. He was an older gentleman at that time. I found out that he existed, found his number somehow, and would call him periodically and talk to him. I had called Frank Ogasawara, who wrote the article for National Geographic from the early 1970s on the Onagadori, the long-tailed chickens of Japan. I'd called him when I was like 6 or 7. I'd somehow found out the university he was at from the National Geographic article. I maybe 6 or 7 or 8 when I did this. Called information to where he was in California, got his number from information, called him, and talked to him about those long-tailed chickens. And so it was not unusual for me to be calling up adults and talking to them about these things. Goldfish, chickens, what have you. I knew F.P. Jeffries. I had his books as an adult. I had him as a kid, and then I had him as an adult as well. And I just turned back to Jeffries. And in one of his books, I don't remember if it's Bantam Chickens or just Chickens, I don't remember which one it's in, but he mentions it in all of his books. And that is that the way to deal with disease is to open up the chicken house and let the sick die off and cull out the weak, and what you're left with you can breed from, and you'll have hardy birds after that. And I knew there was science behind it, because this was not just some, hillbilly from up a holler. This was a poultry scientist. And he wasn't giving you scientific jargon. He was just saying, don't breed from your weak ones. Don't baby them. Don't pamper them. Don't give them any special treatment. Don't medicate them. Don't do any of this. Get rid of the weak. Breed from the ones that never get sick. You won't have any problems. And it's as simple as that. That's really what it is. This led me to doing a long research project. I eventually found a bird, because it found in the literature that you could not have resistance for the two most common diseases homozygous in the same bird. And that's Mycoplasma, which is not the disease itself that causes the problem. The Mycoplasma is a protozoan that colonizes the respiratory tract of the birds, and it weakens them, and then they catch all the secondary infections, so all the coryza and Newcastle and what have you. Whatever's coming around, the birds with Mycoplasma catch it more easily. But if they're resistant to Mycoplasma, that is, if they have true genetic resistance to Mycoplasma, they don't catch all those secondary problems, at least not as easily. It's very difficult to give those problems to them unless they get sick with something else. Then the other problem is the Marek's virus, which causes a whole host of problems. So the genes for resistance, the major gene for resistance to both Mycoplasma and Marek's viruses, were alleles at the same locus, so you could never have them homozygous and have both. So you had to have either homozygosity for Mycoplasma or homozygosity for Marek's. Eventually, I found a bird that had homozygosity for both, and my guess, and it also had breeding value for that, so it was not a fluke. I guessed that this bird had what I was looking for, and that was a chromosomal realignment, where the gene for one of the forms of resistance had jumped to a different point on the chromosome, and so now you could have homozygosity for both. So eventually I sent samples of that bird to a different scientist that I was working with at that time. He typed them. That is what had happened. In time, that research went into the poultry industry. During this time when I was doing the research work, then what I was doing on my end was I was setting up the test matings, and I was then sending samples to other researchers, genetic researchers in university and industry laboratories, who were then testing the samples and determining what I had based upon my observations and descriptions that I had provided to them. And because I am very good at observation and I'm very detail-oriented and I see patterns and I have the scientific training and background, I was able to see these patterns and relay that to them so that they could look for what was going on in the genome. So, because I had depopulated, and then even when I brought in new birds, the same problems happened again, and then I had Red Jeffries, what I ended up doing was just going through my flock and basically getting rid of everything that showed any form of illness at any point. And I ended up with about 6 birds left. And out of those 6 birds, there was not a pair of any breed. So I had 6 birds, each of a different breed, each with a different set of genes, each a different color variety. As I started breeding these resistant birds in order to make more resistance and to study the resistance and to see how extreme I could get it and how it behaved. Is it recessive? Is it dominant? How does it work when you cross it out to non-resistant birds? So I would bring in birds that were non-resistant, both for outcrosses and as an inoculant, because, in a population where there's no disease active, the pathogen can die out and leave you with birds that you think are immune but aren't. So it was important to always have exposure, and by bringing in birds that did not have the resistance, which I had to have to do the test matings, then I was ensuring exposure to make sure these birds really were resistant. That then led to the color research that I did, because I had all these different varieties. And as I brought in new birds, I would occasionally find a new resistant bird. And so my main thrust in developing and in researching how extreme you could get resistance was to take the most resistant and breed them to the most resistant. Now, I would breed out resistant to susceptible as well to study how the genes worked, and found that these are both basically both Marek's and Mycoplasma resistance genes are recessives. But they clearly also have minor genes modifying them and strengthening them, because when you breed resistant birds together, you can get more and more and more resistance. Okay, so as I was doing that, I was also studying the genes. And there's this whole body of poultry research available from Crawford and Carefoot and Hutt and Jeffries and Hollander and a whole host of different people, scientists, poultry scientists, who have studied the genetics of color and form. And so a lot of times what I was doing was simply making a test mating to confirm or refute their findings. So along the way, I was able to do a massive, broad range of color experiments. Out of that, throughout the process, I was developing my own birds, my own breeding techniques. I was exploring different breeding techniques. And eventually, by about 2004, that led to me starting to write the manuscript of my first book, which is An Introduction to Color Forms of the Domestic Fowl. I then started working on the manuscript for the second book, which is An Introduction to Form and Feathering of the Domestic Fowl. So the first book covers color and pattern. The second book covers form and feathering. By 2008, 7 or 8, I was getting tired of working with the birds. I was tired of being attacked. I was tired of, by both chickens and chicken people. I was tired of chicken dust. I'm allergic to chicken dust. I'm allergic to chicken dander. I was tired of having to wear masks, or if I didn't wear masks, I had sinus problems continuously. I was tired of chasing around chickens. I was tired of animals in general. I had done research work in crossing out jungle fowl. I wanted to know how chickens arose. One of the things I came to realize as I was working with all of these color genes is that there was no way this simply is all mutations from the red jungle fowl. There had not been enough time. Yes, they've probably been domestic for 7,000 years. I still don't think that's enough time for all the different phenotypes that we have. So I began to look into the possible hybrid origin of chickens. I got a lot of flack from people for that at that time, but I continued to pursue that, and I came to realize, yes, and now research is clearly showing there is nuclear DNA coming from the other 3 jungle fowl species. Also, I'd always been keeping a few snakes, but I started to breed more snakes around 2002 or so, because I wanted to look at hybridization. I wanted something that I could use as a model organism and as a comparison to the work I was doing with the jungle fowl and the chicken. So I was breeding hybrid snakes amongst the North American colubrids, king snakes, milk snakes, corn snakes, rat snakes, Pituophis of all forms, the bull snakes and gopher snakes and pine snakes. So basically Pituophis, Lampropeltis, and what was then called Elaphe and is now called Pantherophis. And so I dabbled with that up until about 2010 or 12. So about 2008, I've done this for a long time. I've been growing daylilies the whole time. I've been thinking about breeding daylilies. I've been seeing problems arising in each new year that I was buying daylilies. I was seeing more and more inbreeding depression. I was seeing weaker plants. I was seeing huge amounts of fertility in the tetraploids. Even though they were big, robust plants, they still had these problems that I could tell from my work with the hybrids amounted to something like chromosomal misalignments. And I came to realize that came about because tetraploids, it's not that the hybridization is necessarily the problem in the daylilies. The daylily species hybridize fine and all produce pretty much 100% fertility and no problems. The problem came from the fact that the tetraploid daylilies were created through colchicine conversion of diploid plant materials. And when you do that, it kind of messes up the chromosomes, and it takes a few generations of careful selection to get them back to a normal fertility level. You have to realign all of those chromosomes to make sure everything is matching properly, and that you don't have, you'll get partial chromosomes sometimes, or you won't get full conversion. There's this whole host of problems. And so like through the early 2000s, the late 90s, as I was growing tetraploids for the first time, starting around 1988, I was starting to see that there were some problems, and there were clearly more problems in the lineage as time went on. So I had been thinking for a long time about breeding daylilies, and so by 2008, I am done with the chickens. That is with the breeding them. I've never gotten away from them, but with the breeding them and keeping them, by 2011, 12, I'm done with the snakes, and I passed all of those on to other breeders. I started heavily in daylilies about 2008. And so that leads us up to the current time, which is that I developed this daylily breeding program, and my point in creating it was that I wanted to fix the tetraploids. That is, I'm not saying there's anything wrong with people's flower selection. The daylily breeders, my hat off to them. They have done the most incredible job of selecting the most amazing, breathtaking, awe-inspiring array of flowers you can imagine. They've gone in the most amazing directions. They've selected up things that are simply off the hook. But the tetraploid breeders had never taken the time to fix these chromosomal misalignments and to fix their fertility issues. And that to me is untenable. The reason it's untenable is not just that I'm a snob, but because that is going to create bottleneck, and that is going to create long-term inviability. And why waste all that time on something that's going to end up petering out? So I devised a program where I would go to species and near species material that exists at the tetraploid level that is not closely related to the rest of the tetraploid gene pool, but is more closely related to species and has high fertility. Now, there's not many things like that, but I was lucky to find a couple of things that have that. Notified Ground Crew by Kurt Hansen has that because it has a lot of early diploid hybrids, and the early Tetrina, which is thought to be a seedling I think it's Tetrina's daughter, actually, that is in Notified Ground Crew. But Tetrina's daughter comes from Tetrina, which is allegedly a seed conversion from Hemercalis citrina. So Notified Ground Crew, both on that side and on the other side, which is the Tet conversion of purity, has a lot of species genes, and it's probably only like F3, 4, 5 from species. The other thing I used is Ancient Elf, which Jamie Gossard had converted the old type daylily nutmeg elf and the older type daylily itsy bitsy spider, which even though those come from like the 60s, 70s, 80s, they are closer to species. They're very species-like, and so both of the conversions were fertile. He crossed those. Ancient Elf is, in my opinion, the best of the seedlings from that cross. It is very fertile. It is species-level fertile. So is Notified Ground Crew. So I used then the triploid. Before I got plants, I talked to researchers. I found a researcher named and daylily breeder named Dr. Joseph Halliner, who was breeding out in the Pacific Northwest. I talked to him. He advised me that I should use certain triploids. I got from him Han Cow, which is a clone of Hemercalis fulva, and I got one that is a not officially named Korean, but it is a clone of the Hemercalis fulva, probably the Daryl Apps found in South Korea in the Seoul Botanical Garden at the University of Seoul, and brought back to the U.S. in 1984. It's very fertile with both dips and tets. It's a triploid. It has never been used much in breeding. Dr. Halliner had used it, but he had never introduced anything out of it. He advised to me that it was the best thing I could use for going out to tetraploids. I bought it from him. And then I also found a plant called Implausibility, bred by Nick Chase, that is a cross between Hemercalis fulva europa, the famous ditch lily that grows in the ditches all over North America, that's an introduced plant, it's not native, that he crossed to the old diploid that maybe is a conversion or maybe produces unreduced gametes, or no one quite knows what exactly. Ed Murray is the name of that clone. So he produced this plant called Implausibility that is an F1 seedling from the species clone Europa. Now Europa is a triploid that's nearly sterile and very difficult to work with, but he did get this one seedling, and then Implausibility is pretty fertile. See, there's fertility restoration already achieved, probably kind of by accident. I mean, I don't think Nick Chase set out to make fertility. I think that's just what happened. He set out to just make something out of Fulva Europa, and I'm glad he did. So those are the 4 base plants that I built my program on, and they become the basis for breeding. I then started to bring in the fanciest and most modern of the tetraploids from the fancy hybrid later generation gene pool, and I began to raise those in difficult situations. I've always been working with permaculture too. I've not brought that up yet, but permaculture has been a major focus throughout the 1990s and 2000s. So in my 20s and 30s, 40s, that was a really important concept that I worked with a lot. So I had the concept of zero input agriculture and testing things in a way that you tested them through hardship, and that also comes from the Dune books, which is where I found Liebig's Law of the Minimum, which is a concept in agriculture and horticulture that says that the least available nutrient in the environment becomes the limiting factor. The way Frank Herbert dealt with that is that he made a saying he called the Amtal rule, which is to know a thing's true nature, you have to push it past its tolerance level. And I had seen this also with the chicken research, that the way I could get the true results to make sure I was inoculating the birds was to expose them to the susceptible birds so that there was no effort to treat the disease and you let it run its course. That's the same kind of concepts. This, is the way old farm breeders worked. It is basically resistance breeding and salvage crossing. So I knew there were disease problems in daylilies. I knew there were these weaknesses. There was this bottleneck. There was these chromosomal misalignment and fertility problems. And so what I did to find the strongest of the hybrids, of the later generation hybrids, was to bring them in, test them by giving them no inputs. No babying, no pampering, no watering in droughts, no fertilizer, no protection from late spring freezes, no frost blankets in the winter, no growing them in greenhouses, none of this babying and coddling. Just you're out in the garden in the average soil, which my soil is not good. I'm on the farm on a southern exposure that's on a hillside that's basically a mixture of not very fertile clay and red sand with a little bit of topsoil over it. And some of my gardens have no more now after 20 years of growing in them, but they started out without it. So I just planted them out and I said, okay, what's going to do well? Most things didn't do well. The tender stuff from the south would tend to die out in the winter, or you'd get freezebacks, or they'd have problems, or they just couldn't grow. Things that are supposed to have a 3-foot scape would have a 6-inch, 8-inch scape down in the flowers. Lots and lots and lots of problems. But what I eventually found were a handful of very strong, very fancy, beautiful ones. The fertility's not as good as these more species types, but I crossed them back onto those. And that's what I've built my program with the daylilies out of. So you can see each step along the way, all of these things are feeding in together. But not only are those things feeding in together, because there's been an aesthetic throughout the whole time. When I was breeding the chickens, I bred distinct traits into them. Like, for instance, I found the genes that can make like a really widespread fantail. You have to have the orientation of the feathers turned so that they're flat. Instead of this direction, they go this direction. The tail is fanned open. It's up and open and separate, and the feathers are turned. There's 4 genes there that come together to make that. And so by the time I quit with my poultry work, the birds that I had produced had these big fantails. So that's an aesthetic concern. And that fantail to me is similar to the Tosakan tail in the goldfish. But then it's also similar to like the structure of a hoop skirt that you would make for like a Southern Belle in a stage show, or like the hoop skirts in Gone with the Wind. So it's always, all of this aesthetic is feeding in together. Or another thing you might say, the fan tail on the chicken is similar to the Tosakan tail of the goldfish, which is similar to the Elizabethan ruffed collar. So I see these aesthetic things coming from all these different directions that I can bring together. So I had the gradual throughout my life, the permaculture and the domestication and the hybridization and the resistance breeding and the understanding about chromosomal mismatch and chromosomal misalignment that I gained through looking at hybrids that I then was able to apply to the instances, to this instance of the colchicine conversion and the problems that had created in the tetraploids, that all brings to bear on my program. So, like, it would have been easy enough to just take those 4 base species and near species, and just crossed those and made a new line of tetraploids out of those. But that wasn't going to work because I love species flowers and they're beautiful, but they're not beautiful enough. I like the colors pink and lavender and near white, which do not occur in the species. I like the blue eye zones. I like ruffled edges, though not out of control. I like the flower to be able to open. I like fringed edges, teeth. I like what's called pie crust edging. I like broken patterns in the eyes. I like all the fancy genes. I like them in moderation so that they don't ruin the plant and the plant can open and that they don't cause problems. But I do love the fancy, modern, artistic, beautiful, aesthetic genes and phenotypes that occur in the modern garden daylily. So it wasn't enough just to make like a permaculture daylily, which I've done. The F1 plants from this crossing program are great permaculture plants, and I do breed in a permaculture direction as well. But I'm also always bringing in the fancy genes, because the goal is not just to have a strong daylily with a species look, or to have a fancy daylily that's over here on these kind of not so great plants with poor fertility, but to combine those. And then there's another aspect of my aesthetic that I brought to bear on the daylilies, which was that I wanted giants. Because I always thought when I looked at tetraploids, they had these big thick scapes and big thicker foliage. Why is no one exploiting this? There are genes in daylilies. A.B. Stout talked about it in the 30s and 40s. There are genes in daylilies where you can make these big, tall daylilies in the diploid level, but they have thinner scapes and they kind of fall out, and I don't love that. But I always thought, if you've got these big, thick scapes in the tetraploids, why can't you then make big, gorgeous tetraploids that are giants? Get them up 6 feet. Make these big, thick scapes that'll hold up on these big, gorgeous, beautiful, robust plants that are vigorous and fertile and disease-resistant, but also have beautiful modern flowers in these other colors and with some of the bells and whistles and fads that everyone has lost their mind over. And so my program is a combination of the science and permaculture, resistance breeding, my understanding about all of those things, my desire to have strong, fertile, vigorous, disease-resistant bases to work from, and then bringing in the artistic sense, the artistic vision, the desire to be an artist and to make something more beautiful and something more aesthetically pleasing, and to combine that on a strong base. And as I always say, Leonardo da Vinci did not paint the Mona Lisa on an old snotty tissue. And that is because he was a fine artist and he wanted his art to last. I want my art to last. I don't want to create a daylily that has to be kept in a greenhouse or dies in a real garden after 4 years if you didn't get to divide it in the 3rd year. I want my daylilies to be big, gorgeous, beautiful pieces of art that you can't kill, that are hard to kill, that you would have to work to get rid of them once you've got them, and not in the sense of like the ditch lily. I breed out the rhizomatous gene, so I'm not looking to make invasives. I breed clumping plants. But what I mean by that is a plant so strong that it just has the vigor that it thrives in any situation you throw it in or at it, and it is also beautiful. And being able to look at the science and understand that we are in a changing climate, whether anyone wants to accept that as reality or not, I want my daylilies to survive in situations where if times get tough and people can't lavish huge sums of money into care for these plants, that they will still survive, that they will survive in harsh conditions, that they will survive extreme heat and extreme cold and extreme hardship and not getting fertilized and not getting watered in drought, and still be something beautiful that we can enjoy. Because even if we go into a difficult time as a species, we should not lose our sense of beauty. We should not lose our sense of art. Everything that can be done in domestic animals and plants has not been done. There are hundreds of chicken phenotypes just begging to be made that have never yet existed. There are many things in all the plant areas, though plant people are better about exploring than animal people. But there are all these phenotypes that have not yet been made, that have not yet been seen. And I want to encourage you to explore, be an artist, but be a good artist, be a fine artist, be an artist that works with fine materials. And if you have to make, artists used to make their own canvas. They didn't pop down to the art store and buy a canvas. They used to make their own canvas. They used to stretch their own canvases. They used to find the proper substrates. They used to make their own pigments. They used to make their own paints. They ground their own pigments and made their own paints. So I want you to be that, and I want to impress upon you that this is possible to do, because you can go out and create good stock that you then turn into fine art that will persist past you, like all great artists. So that is an overview of my breeding and work, and I wanted to give you that at this point. So as I'm talking about all of these disparate things as we go along, if you want, you can refer back to this one and kind of get a grounding of what I've done and how it brought me to where I am now. Thank you for visiting my channel. I hope this video was interesting to you. If you would like to know more about this subject, leave a comment or question below in the comments section. Please leave a like on this video and subscribe to the channel. Click the bell notification to be alerted when new videos post. You can find my poultry books on Amazon at the link below in the show notes. My daylily website, sundragondaylilies.com, offers information on booking me for consultations on your specific genetics questions or mentoring for your breeding projects. It also lists all of my daylily introductions, the cultivars that are currently available, and links to my blog where you can find the bulk of my daylily writing. Thank you for joining me for this video, and I hope you'll be back for more. Have a great day.